Hello Year 8. Please pause the video while you copy a rectangle is a quadrilateral with 4 right angles and the diagram. Okay, so let's look at the properties of a rectangle. Now, a rectangle is a special type of parallelogram as well. So we can say that these sides are parallel and these sides are parallel. Remember to add those annotations to your diagram. Opposite sides of a rectangle are equal. So I can put these lines in. Add those to your diagram too. The diagonals of a rectangle bisect each other. Hopefully you've got a ruler so you can draw your diagonals nice and straight, like mine. So this length is equal to this length, and this length, oh I need 4 there, is equal to this one. Now also, which is different from a parallelogram or a rhombus, the diagonals of a rectangle are equal. So even though I put 4 lines here, I don't actually need to. I can have 3 lines because all of these halves of diagonals are the same length. Let's have a look at using these properties then. So let's start with the diagonals. I'm given that this is 6. Because this is 6, x and y and z are also 6. So I can write that as a single statement. My reason? So really that's 2 reasons. The diagonals are equal and they bisect each other. Okay then, now let's have a look at alpha. Well, alpha is vertically opposite 50, so it must be equal to 50. Beta lies on a straight line. It lies on the diagonal with 50. So we know that angles on a straight line are supplementary. They add up to 180. So beta plus 50 equals 180 because I'm mixed up my T and my A there. And so I can subtract 50 from both sides to get beta equals 130. Finally, I've got theta here. Now, if we have a look at this triangle, I know that these 2 sides are the same length because diagonals of a rectangle are equal and bisect each other. So this is an isosceles triangle, and this angle here is also theta because we know that base angles of an isosceles triangle are equal. So I can say that theta plus theta plus 50 equals 180. Now, rather than writing out this here, I'm going to call it reason 1, and I'm going to put 1 down here, and angles in a triangle are supplementary. Within a single question, it's okay for you to reuse reasons, so labeling it with a number and writing it again. But if you move on to a new question, then you've got to write the reason out again. So I can collect my like terms here. 2 theta plus 50 is 180. I can subtract 50 from both sides. And I can divide by 2. So that's an example to help with rectangles. Now we've also got to think about squares. And a square is a rectangle with 4 equal sides. A square is actually a parallelogram and a rhombus and a rectangle. It's a special version. So the 4 equal sides tell us we've got 4 equal sides here. That it's a parallelogram tells us that this side and this side are parallel, and this side and this side. All of the angles are right angles because it's a rectangle. Opposite sides are parallel because it's a parallelogram. The diagonals of the square are equal and bisect each other at right angles. They're equal because it's a rectangle. They bisect each other at right angles because it's a rhombus. So this and this and this and this, they're all the same length. We have a right angle. And also, because it's a rhombus, the diagonals of a square bisect the angles. So this angle here, I'll call it alpha, is equal to this angle here. Because this is a right angle, I know that alpha is equal to 45 degrees. And that would be the same for all of the angles around my square. So now you have that information, you need to use those properties of rectangles and squares to do exercise 13C, question 1. To find t is a little bit tricky. You do have the information for it, but you'll have to cast your mind back to earlier lessons in the year and think carefully about this whole question E as well. You'll need to work out these angles to help you. Let me know if you have any questions. Thank you.